Now in this video I'll be doing the Bayes theorem. Now the Bayes theorem. Now let me talk about like we have already talked about the conditional probability, that is probability of A given that B has already occurred. It is equal to probability of A and B occurring together divided by probability of B. Now let me take the reverse probability, reverse conditional probability, that is probability of given B given that A has already occurred is equal to probability of B and A occurring together divided by probability of A. Now if I say that probability of A and B occurring together is equal to probability of B and A occurring together, which means that what I'm setting these two probability equal. Now now this probability of A and B is equal to probability of A given that B has already occurred multiplied by the probability of B, and over here it is going to be equal to probability of B given that A has occurred multiplied by probability of A. Now if I divide both sides by probability of B, so I will get the probability of A given that probability of B is equal to probability of B given that probability of A into the probability of A divided by probability of B. This essentially is the Bayes theorem, where we can by this formula we say that we can calculate the conditional probability by using the reverse probability and multiplied by the probability of the other event divided by the probability of this event. Now we will be able to we will understand this Bayes theorem with the help of an example. Now I'm given this example that a particular study showed that 12% of the ground workforce in cement factory will likely develop cancer at some point in their lives. A ground worker has 95% chances of a positive test result from medical examination. The worker not working as a ground worker has 6% chances of getting a false test result. So what the question is asking me is what is the probability that a man has cancer or the workforce has cancer given that he has a positive test result. Now in this case, now let me first read the first sentence. The particular study showed that 12% of the ground workforce in a cement factory will develop cancer. So which means that the probability of the cancer is going to be equal to 0.12. A ground worker has 95% chances of a positive test result, which means that probability that he will get a positive test result given he has a cancer will be equal to 0.95. Then moving on, it says that a worker not working as a ground worker has 6% chances of getting a false test result, which means that the worker will get a positive test result given that he does not have cancer is equal to 0.06. Now he says what is the probability that a worker, let me name it as worker, has cancer given that he has a positive test result. So the question is asking me to calculate the probability he has cancer given that he has got a positive test result. Now let me write down it in the shape of the Bayes theorem, that probability of cancer given that he has a positive test result. Now let me write down the reverse probability, that is probability of positive test result given that he has cancer into the probability of cancer divided by probability of positive test result. Now I do have the probability of positive test result and the cancer. I do have probability of cancer, but I don't have the probability of positive test result. In this case I will be using the tree diagram to calculate the probability of the positive test result. Now in this case there are 12% chances that the person will will have the cancer, and which means that 88% of the workforce will not have the cancer. Among this 12%, 95% of the people will get a positive result, and the 0.5%, leftover 5%, will get the negative result. Now among them, those people who don't have the cancer, 6% people will get the positive result, while as the 94% people will have the negative result. Now I need to calculate the probability of the positive result. Now if we as we have already explained in the previous lecture, it is the calculation of the marginal probability, which is equal to the sum of the joint probabilities occurring together. So which means that it is going to be equal to the probability of the positive result and the cancer plus the probability of positive result and not cancer. So in this case I have to multiply these two, so which is going to be 0.95 into 0.12 plus probability of positive result and not having cancer, which is going to be 0.06 into 0.8. It's simple as we calculated the marginal probability in the previous case. So this is going to be 0.1668. Now probability of positive result given that he has a cancer is equal to 0.95 multiplied probability by the probability of cancer. The probability of cancer is equal to 0.12, and given that probability of the positive result, that is 0.1668. Now it is equal to 0.683. So this means that 68.3% is the probability that the worker has cancer given that he has the positive test result.